Hello, welcome back. Here we are again. So 10.5, remember to take a deep breath, loosen up, don't get tense over this, do whatever you can, do the best you can, and just keep working at it. Do the best you can, keep working at it, making sure you're turning stuff in, and that way I can get things updated and I can see how we're doing. So 10.5, angle relationships in circles. This will deal with chords and tangent lines and other chords. What relationships exist among the angles and arcs formed? Woohoo, a relationship lesson. Yippee. Okay. So, again, a lot of properties, a lot of rules. If you can apply them, find out which rule is working on it, the questions are asking, you'll be okay. So, the first thing we have is we have a tangent and an intersected chord. So it looks like this. We have a chord, and then we touching a tangent at a specific point. Remember, a tangent line just touches at one point. So this angle that's formed down here is going to be half of this arc. So kind of just think of a inscribed angle. So just think of an inscribed angle. It's always half that arc. So that's what happens here. So if I have a chord and a tangent, if this is 280, and I'm looking for this angle, it's going to be half the 280. This angle 1 would equal 140 degrees. So these are a linear pair, so this should be 40 degrees, which means this over here should be 80 degrees. 280 and 80 would equal the 360 that a circle should add up to. Okay? Likewise, if this angle is 80 degrees, this arc should be 160 degrees. Okay, on the other side of the angle, that would be 100. That would make this arc 200. 200 plus 160 would give us a 360 for the circle. Not sure what this is about, but three places that lines can intersect. They can either intersect on the circle, inside the circle, or outside the circle. And that's kind of what we're looking at, different situations for that right now. So we've done on the circle. Those are inscribed angles. So if this is x, this is 2x. Okay. Inside the circle, that's the next one. So these are just two chords. This is not the center. Okay. So that's different here. This is not a central angle. These are just two chords. They want to find that x. It is half the sum of the two angles. So that's what it's saying. The measure of angle 1 is half of this arc plus this arc. So if I'm looking for x, I have to take the two arcs, the one that it's forming and the one that is opposite of it, of its vertical angle. So x is going to equal 100 plus 90 divided by 2. So 190 divided by 2 would be 95 degrees. So this would be 95 degrees, and those are vertical angles, so that's also 95 degrees. These form a linear pair, so they're supplementary, so this would be 75 degrees. Okay, is that right? Or 85? How about 85 degrees? 85 sounds better. So those two would be 85 degrees. 85 and 95 is 180 last time I just checked right now. Yeah, of course. Okay. So, and you maybe have to work that the other way as well. So I know the angle. I know this arc. I'm looking for the other arc. So 50 equals x plus 40 divided by 2. So multiply the 2 over first. 100 equals x plus 40 minus the 40. X is going to be 60 degrees. So this arc is 60 degrees. So the angle is outside arc plus opposite arc divided by 2. Angle equals outside arc plus opposite arc divided by 2. Okay, angles that are outside the circle. So those are angles that are inside the circle. On the circle were inscribed angles. Angles that are outside the circle, you can have three different situations. You either have an angle that forms a chord or a secant line and a tangent, two tangents. So this is a secant line, secant and tangent line. You can have two tangent lines, or you can have two secant lines. Now the nice thing is no matter the situation, it's always all the same formula. It's outside arc minus the inside arc divided by 2, or times 1/2, equals the angle. Okay, so no matter what situation you have, if it's an outside angle, the angle equals outside, the bigger arc, minus the inside arc divided by 2. So if the point is outside, you're taking outside minus inside divided by 2. If the point was inside, you're taking outside, the one that's the intercepted, there we go. Sorry, if it's the point is inside the circle, you're taking the intercepted arc plus the opposite arc and dividing that by 2. So that's one of the questions you're asking. Is my angle inside the circle, or is it on the circle, or is it outside the circle? That's going to tell you which formula you need to use. So here, my point is outside the circle. I have 2 arcs. My angle is given, so 40 equals the outside arc, 132, minus the inside arc, x, divided by 2. So angle equals outside minus inside divided by 2, multiply the 2 over, so 80 equals 132 minus x. Solve for x is going to be 132 minus 80, which is 52 degrees. So this one has to be 52 degrees. Okay. Likewise here, this is 200. I made this a little bit different. I'll do another example. But remember, if you have 2 tangents, the easiest way to do this one is know that a circle has to have 360 degrees. So if this is 200, x has to be 360 minus 200. So that'd be 160. Maybe not the way they exactly want you to do it, but that's the easiest way to do it. You could say 50 equals 200 minus x divided by 2. And then you get 100 equals, I didn't add that up. I didn't use good numbers, very good numbers here. I didn't check my answer. Okay, we're not going to do that. So 360 minus 200, that one has to be 160 because these are 2 tangent lines. Okay, so if this arc is 200, this arc has to be 160. They have to add up to 50. So that angle should have been, if I would have checked my math, 200 minus 160 divided by 2. So that's 40 divided by 2. That should have been 20 degrees. Bad problem. Okay, that is what's referred to as a circumscribed angle. An angle whose sides are tangent to a circle. So that's this 2 tangent problem. That's a circumscribed angle. So if you have a circumscribed angle theorem, so here you have a circumscribed angle, and they've drawn the radius. That's the radius. Remember that the radius and a tangent line are perpendicular. So radius and tangent line are perpendicular, and a quadrilateral has to have 360. So if this is 90 degrees and this is 90 degrees, that only leaves 180 degrees for these 2 right here. So those 2 angles have to add up to 180 degrees. Those angles have to add up to 180 degrees. Okay, so the measure CD is tangent to the circle. Find the indicated measure. Measure of angle ABC. Well, if this is 70, this angle right here is 70, ABC has to be 180 minus 70, so that'd be 110 degrees. So this has to be 110 degrees over there. Linear pair has to be supplementary. Measure of arc AB. So AB is right here. Okay, so that's going to be twice. So we had our, it's 1014 tangent intersected chord theorem, okay, that the angle is half of the intercepted arc. So that means the arc is 2 times the angle. The arc is 2 times the angle. With the angle 70, the arc has to be 2 times 70, that's 140 degrees. AEB, same thing, 2 times 110, that has to be 220 degrees. Those two right there should add up to 360. Okay, exercise 4 and 5, measure of arc ADB. A to D to B is 220. Measure of angle B is 21. So they want the measure of arc A to B. Well, A to B, they said ADB is 220. So the other part of that circle has to be 360 minus 220. So that'd be 140 degrees. Okay. And ACB, they want the measure of angle ACB. So ACB, notice, intercepts this arc right there, but it intersects it on the outside of the circle. Okay? So what I would do is I would look at this angle here. So we may say, oh, that's an outside. We need to use one of our outside rules, which is one of these, which we can do. That is possible, but then you get into we have this, we don't have this. It might get a little bit more confusing. What I would do is I would look at this angle here. This is on the circle, so we know if this is 220, this has to be 110. So that angle has to be 110. Now you have a triangle. 110 and 21 is 131. So we're going to take 180 minus 131, and we'll get 49 degrees. That's how I would do that one. Question 6. Find the angle of x. Find the value of x. X is inside. The vertex is inside the angle. So I'm going to use angles inside the circle theorem. Common name. Okay, so I have to add up the two arcs and then divide by 2. So x is going to equal 92, this arc, plus 50 divided by 2. So 92 plus 50, divide that by 2, you should get 71. Okay. Question 7, they want the value of x. Now x is a supplementary to this one. So what I would do in this case is I would go ahead and find this angle and then find out what this one needs to do from there. So I would find this value right here, y. And I know y is going to be 35 plus 97 divided by 2. So 35 plus 97, divide that by 2, 66. So y is 66. So this angle here is 66 degrees, which means 5x plus 14 has to equal 180 minus 66. So 180 minus 66 is 114. So 5x plus 14 equals 114. Minus the 14 and divide by 5, you get x equals 20 on that one. Number 8, this is outside. Outside, so I know that 38 has to equal x minus 72 divided by 2. X minus 72 divided by 2. So multiply the 2 over, you get 76 equals x minus 72. So x equals 148. Add that over. Okay, that is using these theorems here. Outside arc minus inside arc divided by 2. Some more formulas here. Okay, so we're just going to say, okay, 4x plus 8 minus, make sure you use a parenthesis, 3x plus 2. Divide all that by 2, that has to equal 28. So make sure this parenthesis here, you have to distribute that negative sign. So it'd be 4x plus 8 minus 3x minus 2 should equal 56. Multiply that over, times that. So 4x minus 3x is x, plus 6 equals 56, so x equals 50. The only other one, looking through the assignment, might be something like this. This is circumscribed angle, this is 60, this is 20x. So you don't have an expression for this one. So if this is a circumscribed angle, you know the whole thing is 360, so this has to be 360 minus 20x. So you have to take 360 minus this one, that'd give you that one. So if I take 20x minus, that's the outside, minus the inside, again, parentheses, divide that by 2, that should equal 60, so that should equal 120 once you multiply the 2 over. So 20x minus 360 plus 2x. If you don't distribute the negative, sorry, that should be plus 20x. 20x. If you don't distribute the negative, the x's will cancel off, you'll be confused. That equals 120, multiply the 2 over. So add the 360, and you get 40x equals 480. 480 divided by 40 is 12. So x equals 12 in that case. Okay, and that should take care of most of the examples. Some of the later ones, try your best. Just do what you can to figure them out, or ask during some of our class time, and I'll go through them with you if you want. But good luck. Hope you're doing well. Miss you all, and I'll hopefully see you online soon.